All right, we're going to be looking at rotational kinetic energy and conservation of energy. Specifically, we're going to be looking at a cylindrical disc rolling down an incline. Show here the incline and the disc at YI, and we'll allow it to roll down to position YF, which is a change in height of h. We have the cylindrical disc, which has radius r. And the question is, what is the speed of a disk when it reaches y final? We're going to use conservation of energy, and conservation of energy requires what? As I've said in previous sessions, write down your answer first, pause the video, then write down your answer, and then check it by proceeding. So it's simply that the change in potential energy plus the change in kinetic energy is equal to 0. We assume the system is isolated. What are the two forms of kinetic energy? Well, we have the translational kinetic energy because the center of mass of the object is moving with some linear velocity. And then we have the rotational kinetic energy because at the same time it's moving, it's also rolling. And we can write that as the change in gravitational potential energy plus the change in translational kinetic energy plus the change in rotational kinetic energy is equal to 0. And we recall that the translational kinetic energy is 1/2 mv squared and the rotational kinetic energy is 1/2 I, the moment of inertia, omega squared, the angular velocity. We can then write minus mgh plus 1/2 mv squared plus 1/2 omega squared equals 0. And in this case, we are assuming the initial velocity is equal to 0. How is the angular velocity related to the velocity of the center of mass? That's the velocity of the center of mass is equal to the radius of the cylindrical disc times the angular velocity at which the disc rotates. So the equation becomes, take a minute and work it out, minus mgh plus 1/2 mv squared plus 1/2 I v squared over r squared. And of course we have that the moment of inertia for a cylindrical disc is 1/2 mr squared. So work out the equation with that substitution, and I'm going to substitute for this, I will substitute in for I. And we have minus mgh plus 1/2 mv squared equal to 1/2 times parentheses 1/2 mr squared, v squared over r squared, and you have that the two r squareds will cancel out. Finishing up the problem, we have mgh is equal to 1/2 mv squared plus 1/4 mv squared, and you get the final answer that v is equal to the square root of 4gh over 3. What if it was a block sliding down a frictionless incline? What would the final velocity be? Compare that to the velocity of the rolling object and determine which one is larger, the rolling object at the time it gets to YF or a block sliding down a frictionless plane by the time it gets to YF. End of module.